Okay, hi everyone, welcome back to this video series on data centers. Subnetting Basics. In chapter 5 you learned how to define and find the valid host range used in a Class A, Class B and Class C network address by turning the host bits all off and then all on. This is very good, but here's the catch. You were defining only one network. What happens if you want to take one network address and create 6 networks from it? You would have to do something called subnetting, because that's what allows you to take one larger network and break it into a bunch of smaller networks. There are loads of reasons in favor of subnetting, including the following benefits. Reduced network traffic. We all appreciate less traffic of any kind. Networks are no different. Without trusty routers, packet traffic could grind the entire network down to a near standstill. With routers, most traffic will stay on the local network. Only packets destined for other networks will pass through the routers. Routers create broadcast domains. The more broadcast domains you create, the smaller the broadcast domains and the less network traffic on each network segment. Optimize network performance. This is a result of reduced network traffic. Simplified management. It's easier to identify and isolate network problems in a group of smaller connected networks than within one gigantic network. Facilitated spanning of large geographical distances. Because WAN links are considerably slower and more expensive than LAN links, a single large network that spans long distances can create problems in every area previously listed. Connecting multiple smaller networks makes the system more efficient. Subnet-Zero. That should probably be IP Subnet-Zero is now a new command, but in the past, Cisco courseware and Cisco exam objectives didn't cover it, but it certainly does now. This command allows you to use the first and last subnet in your network design. For example, a Class C mask of 255.255.255.192 provides subnets 64 and 128, but with the IP Subnet-Zero command, and now you get to use subnets 0, 64, 128 and 192. That is 2 more subnets for every subnet mask you use. Please understand that this command is on by default on all new routers and all Nexus OS switches. How to create subnets. To create subnetworks, you have to take bits from the host portion of the IP address and reserve them to define the subnet address. This means fewer bits for hosts, so the more subnets, the fewer the bits available for defining hosts. Later in this chapter, you will learn how to create subnets starting with Class C addresses. But before you actually implement subnetting, you need to determine your current requirements as well as plan for future conditions. To create a subnet, follow the following steps. Determine the number of required network IDs, 1 for each LAN subnet, 1 for each WAN connection. Determine the number of required host IDs per subnet, 1 for each TCP IP host, 1 for each router interface. Based on the above requirements, create the following: 1 subnet mask for your entire network, a unique subnet ID for each physical segment, a range of host IDs for each subnet. Subnet masks. For the subnet address scheme to work, every machine on the network must know which part of the host address will be used as the subnet address. This is accomplished by assigning a subnet mask to each machine. A subnet mask is a 32-bit value that allows the recipient of IP packets to distinguish the network ID portion of the IP address from the host ID portion of the IP address. The network administrator creates a 32-bit subnet mask composed of ones and zeros. The ones in the subnet mask represent the positions that refer to the network or subnet addresses. Not all networks need subnets, meaning they use the default subnet mask. This is basically the same as saying that a network, meaning they use the default subnet mask. This is basically the same as saying that a network doesn't have a subnet address. Table 6.1 shows the default subnet masks for class A, B and C. These default masks cannot change. In other words, you can't make a class B subnet mask read 255.0.0.0. If you try, the host will read that address as invalid and usually won't even let you type it in. For a class A network, you can't change the first byte in a subnet mask. It must read 255.0.0.0 at a minimum. Similarly, you cannot assign 255.255.255 as this is all ones, a broadcast address. A class B address must start with 255.255.0.0 and the class C has to start with 255.255.255.0. So here you can see in table 6.1 the default subnet mask. So for a class A it's 255.0.0.0. For class B it's 255.255.0.0. For a class C it's 255.255.255.0. Classless interdomain routing. Another term you need to familiarize yourself with is classless interdomain routing, CIDR. It's basically the method that ISPs, internet service providers, use to allocate a number of addresses to a company, a home, a customer. They provide addresses in a certain block size, something I'll be going into in greater detail later in this chapter. When you receive a block of addresses from an ISP, what you get will look something like this: 192.168.10.32/28. This is telling you that what your subnet mask is. The slash notation means how many bits are turned to ones. Obviously the maximum could be /32 because a byte is 8 bits and there are 4 bytes in an IP address. 4n equals 32. But keep in mind that the largest subnet mask available, regardless of the class of address, can only be /30 because you've got to keep at least 2 bits for host bits. Take for example a class A default subnet mask, which is 255.0.0.0. This means that the first byte of the subnet mask is all ones, or 1111111. When referring to a slash notation, you need to count all the 1 bits to figure out your mask. The 255.0.0.0 is considered a /8 because it has 8 bits that are ones, and that is 8 bits that are turned on. A class B default mask will be 255.255.0.0, which is a /16 because 16 bits are ones. 0.000000000000. Table 6.2 has a listing of every available subnet mask and its equivalent CIDR / notation. So 255.0.0.0 / 8, 255.128.0.0 / 9, 255.192.0.0 / 10, 255.224.0.0 / 11, 255.240.0.0 / 12, 255.248.0.0 / 13, 255.252.0.0 / 14, 255.254.0.0 / 15, 255.255.0.0 / 16, 255.255.128.0 / 17, 255.255.192.0 / 18, 255.255.224.0 / 19, 255.255.240.0 / 20, 255.255.248.0 / 21, 255.255.252.0 / 22, 255.255.254.0 / 23, 255.255.255.0 / 24, 255.255.255.128 / 25, 255.255.255.192 / 26. Subnet mask 255.255.255.224 / 27, 255.255.255.240 / 28, 255.255.255.254 / 29, 255.255.255.252 / 30. The /8 through /15 can only be used with Class A network addresses. /16 through /23 can be used by Class A and Class B network addresses. /24 through /30 can be used by Class A, B and C network addresses. This is a big reason most companies use Class A network addresses, since they can use all subnet masks. They get the maximum flexibility in network design. Subnetting Class C network addresses. There are many different ways to subnet a network. The right way is the way that networks best for you. In a Class C network address, only 8 bits are available for defining the hosts. Remember that subnet bits start at the left and go to the right without skipping bits. This means that only the Class C subnet mask can be the following: binary decimal CIDR 00000000 equals 0 / 24, 100000000 equals 128 / 25, 11000000 equals 192 / 26, 11100000 equals 224 / 27, 11110000 equals 240 / 28, 11111000 equals 248 / 29, 111100 equals 252 / 30. We can't use a /31 or 32 because we have to have at least 2 bits for assigning IP addresses to hosts. When subnetting a Class A address the fast way, when you've chosen a possible subnet mask for your network and need to determine the number of subnets, valid hosts and broadcast addresses of a subnet that the mask provides, all you need to do is answer 5 simple questions. How many subnets does the chosen subnet mask produce? How many valid hosts per subnet are available? What are the valid subnets? What's the broadcast address of each subnet? What are the valid hosts in each subnet? At this point, It's important that you both understand and have memorized your powers of 2. Please refer to the sidebar understanding power 2 earlier in this chapter. If you need some help, here's how to get the answers to the 5 big questions. How many subnets? 2x equals number of subnets. X is the number of masked bits or ones. For example, in 11000000, the number of ones gives us two subnets. In this example, there are 4 subnets. How many hosts per subnet? 2y minus 2 equals number of hosts per subnet. Y is the number of unmasked bits or the zeros. For example, in 11000000, the number of zeros gives us 6 minus 2 hosts. In this example, there are 62 hosts per subnet. You need to subtract 2 for the subnet address and the broadcast address, which are not valid hosts. What are valid subnets? 256 minus subnet mask equals block size or the increment number. An example would be 256 minus 192 equals 64. The block size of a 192 mask is always 64. Start counting at 0 in blocks of 64 until you reach the subnet mask value, and these are your subnets: 0, 64, 128, 192. What's the broadcast address for each subnet? Now here's the really easy part. Since we counted our subnets in the last section at 0, 64, 128 and 192, the broadcast address is always the number right before the next subnet. For example, the 0 subnet has a broadcast address of 63 because the next subnet is 64. The 64 subnet has a broadcast address of 127 because the next subnet is 128, and so on. And remember, the broadcast address of the last subnet is always 255. What are the valid hosts? Valid hosts are the numbers between the subnets omitting the all zeros and all ones. For example, if 64 is the subnet number and 127 is the broadcast address, then 65 minus 126 is the valid host range. It's always the numbers between the subnet address and the broadcast address. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.